So bring down the object merge we used earlier, create another merge and connect the main for each loop with the main corridor geometry. Now, like I did with the floor, I also want to place some lights on the ceiling. And for that I'm also going to use the corridor walls to get the design. Not all of the design choices are suitable for ceiling lights. So bring the incoming null down to the bottom of the network, and here we need another object merge, this time only the outer ceiling. To bring the design attribute over, we can use the attribute transfer and limit it to this one primitive attribute. We don't need the color, for example. To exclude some of the design choices, let's head over to the floor network and grab a copy of that wrangle. Then go back to the ceiling network and paste the node right beside the transfer. Now for the ceiling, I don't want any lights for design number 3, the cooling design, since we created some elements right at the ceiling, and we don't want any lights for design number 6, since there we have lights built in. Then start another for each loop. And I think now you know the drill. We're going to find the center points of the panels by using a transform node with adjusted pivot points, reduce the scale to 0 and use a fuse node to get it down to 1 point per panel. After that, bring in the copy node and connect it with a file node. Here select the light BGO file, activate packet instance on the copy node, and since we're now at the ceiling, we need to make a small adjustment. Right before the copy node, we need to create a transform node and rotate the light by 180 degrees. Now they're pointing downwards and can be placed under the ceiling. So let's move this whole node cluster to the side and connect it to the outgoing merge. As a final touch in the floor network, we added the wire pattern, so it makes sense to bring it also into the ceiling network. But first, let's connect the ceiling network into the outgoing merge of the corridor design network. You can already see how everything falls into place. But for the wire pattern, jump into the floor network, and this cluster on the left was responsible for the pattern. So select all of it, copy to the clipboard and back to the ceiling. Here bring down the object merge that holds the ceiling geometry, and the way it was merged before, it is still separated if we combine it with a divide node. You can see that after we remove the shared edges, there are still lines going through the primitive. To get rid of those, just bring in a fuse node right before the divide node. Then paste in the node cluster. Connect the combined primitive into the beginning of the for each loop, and right away we should see a result that works. Bring down the outgoing merge once more and connect the for each end node. And with that, our ceiling is finished, almost. So let's head back up and take a look at the whole structure. Let's see if we find anything out of the ordinary. But for the most part, everything seems to be in order. The walls, floor and ceiling fit together, and all the individual elements are pointing in the correct direction. But there's still one detail that we have not yet corrected on the ceiling. But to make it visible, we have to go one additional layer towards the root network so that we can also see the gateways and the gates. And there it is. The ceiling constructs reach over the whole distance of the corridor and therefore intersect with the gates. We have to apply the adjustment of the width that we used for the walls also for those constructs. We can find that adjustment easily in the place design subnetwork and easiest to copy in the panel design network. Here go to the bottom of the for each loop, and these two nodes are the key. Select both of them, copy them to the clipboard and go back to the ceiling network. Here we need to paste them to the end of the first big for each loop. After we connected them, it's no surprise that we don't find any values. For the width parameter, we have to adjust the path, and in my case it's one less directory to jump over. There's our width, but with the factor it's a bit different. But since our constructs were 4 panels wide, let's start with 4, adjust the transfer node by also adding the multi-attribute to the X component. But since the gates are a bit wider than the walls, we might have to lower that even more. Let's approach this from the other side and type in a 1. Then slowly increase the value and bring the constructs as close as they are allowed to. I think I can eyeball it, but if you want to be sure, you can bring in the gates with an object merge or pin down the viewport in the root directory. I'm going with 3.6 here. That should be enough to prevent the ceiling constructs to intersect with the gates. Now with that final step, the geometry of our corridor scene generator is finished. In the next module, we will touch the networks one last time to split the geometry into groups and use those for material style sheets. In addition to that, we will create a small algorithm that helps a camera to find a path through the corridors. And we're also going to use that path to make the huge amount of lights manageable. In this module, you learned how you can make design alterations controlled by attributes. You saw how you can use math operations in combination with VEX to create procedural cables. And you also saw another example on how to use an existing node cluster and how you can incorporate it in new networks.